Hello there, science fans. Welcome back to another exciting episode where we explore the wonders of everyday life. Today, we're diving into the fascinating world of light bulbs, those tiny yet powerful devices that have revolutionized the way we live. You see them everywhere, right? In our homes, offices, and even on the streets. But have you ever wondered about their journey from raw materials to the glowing orbs that light up our lives? But have you ever stopped to think about how these little wonders that brighten our lives are made? It's a process that combines science, engineering, and a bit of magic. Light bulbs are more than just glass and metal. They're a testament to human ingenuity, transforming simple materials into something that illuminates our homes, powers our cities, and even helps us explore the vast universe. From the delicate filaments to the sturdy glass, each component plays a crucial role. Imagine a world without light bulbs, a world where darkness prevails as soon as the sun sets. It'd be pretty dark, wouldn't it? Our nights would be filled with shadows, and our activities would be severely limited. We'd be stuck relying on candles and lanterns, just like our ancestors did for centuries. While romantic, they were neither efficient nor safe. But thanks to the invention of the light bulb, we have a reliable, safe, and efficient way to light up our lives. This invention has not only brightened our homes, but also extended our productive hours. Now, you might think that something as common as a light bulb would have a simple manufacturing process, but you'd be surprised. The journey from raw materials to a finished light bulb is intricate and fascinating. It's actually a fascinating journey that involves a careful blend of science, engineering, and a touch of artistry. Each step is meticulously planned and executed to ensure the highest quality. We're going to break down this process step by step, exploring how these everyday marvels are born. From the initial design to the final product, every stage is crucial. Get ready to see the world in a whole new light. Join us as we uncover the secrets behind the light bulbs that illuminate our world and make our lives brighter. Let's start at the very beginning, with the raw materials. You might be surprised to learn that the journey of a light bulb often begins with something as ordinary as sand. Yes, the same sand you find on beaches and in deserts. That's right, regular sand, which is mostly made up of a compound called silica. Silica is a form of silicon dioxide, a naturally occurring substance that is abundant in the Earth's crust. Silica is the primary ingredient in glass, and as you know, glass is a pretty important part of a light bulb. The glass not only encases the filament, but also protects it from the environment. But sand alone won't cut it. To transform sand into the high-quality glass needed for light bulbs, we need to add a few other key ingredients. To make the glass just right for light bulbs, we need a few other key ingredients. One of these is lime, which is added to the mix to give the glass its strength and durability. Lime is added to the mix to give the glass its strength and durability, making sure it can withstand the heat generated by the bulb. This is crucial because light bulbs can get very hot when in use. And then there's potassium, which plays a crucial role in lowering the melting point of the mixture. This makes the glass easier to melt and shape, which is essential for mass production. This makes the glass easier to melt and shape, which is essential for mass production. The lower melting point also means that the manufacturing process can be more energy efficient. Now, here's where things get really interesting. To make the manufacturing process even more environmentally friendly, manufacturers often incorporate recycled glass from old light bulbs into the mix. To make the manufacturing process even more environmentally friendly, manufacturers often incorporate recycled glass from old light bulbs into the mix. This not only reduces waste, but also conserves valuable resources. That's right, old bulbs get a new lease on life. By recycling the glass, we can significantly cut down on the amount of raw materials needed. This not only reduces waste, but also conserves energy, as melting recycled glass requires less energy than starting from scratch with raw materials. It's a win-win situation for both manufacturers and the environment. Once we have our blend of silica, lime, and potassium, along with some recycled glass for good measure, it's time to fire things up. The mixture is fed into a giant furnace where it's heated to temperatures exceeding 1,600 degrees Celsius. That's hotter than a pizza oven on overdrive. At these extreme temperatures, the mixture melts into a molten, glowing liquid ready to be shaped. Now, here's where things get really cool. The molten glass is carefully poured into molds that shape it into long, hollow tubes. Think of it like making giant glass straws. These tubes are then cut into precise lengths, each one destined to become the body of a light bulb. But the glass tubes are just the beginning. They still need to be transformed into the iconic bulb shape we're all familiar with. To do this, the tubes are heated once again, this time at one end. As the glass softens, it's carefully flared outward, creating the neck of the bulb. This part is crucial, as it will eventually house the filament, the heart of the light bulb where the magic happens. Now let's talk about the filament, the tiny but mighty component that makes a light bulb actually light up. This small piece of wire is the heart of the light bulb, transforming electrical energy into the light we use every day. The filament is a thin, coiled wire that sits inside the bulb. Its design is crucial for the bulb's efficiency and longevity. When electricity flows through the filament, it heats up and glows brightly, producing the light we depend on. This process is known as incandescence, where the filament emits light as a result of being heated, but not just any wire can handle this kind of heat. The filament must endure extreme temperatures without breaking down. That's where tungsten comes in. Tungsten is chosen for its exceptional properties. Tungsten is a remarkable metal with the highest melting point of any element on the periodic table. It can withstand temperatures up to 3,422 degrees Celsius. 6,192 degrees Fahrenheit. It can withstand incredibly high temperatures without melting, making it the perfect material for light bulb filaments. This durability ensures that the filament can glow brightly for many hours without degrading. Before the tungsten filament is mounted inside the bulb, two conductive wires, usually made of copper, are inserted into the flared neck of the bulb. These wires are essential for delivering electricity to the filament. These wires will carry the electrical current to the filament. Copper is used because it is an excellent conductor of electricity, ensuring efficient energy transfer. A thin glass exhaust tube is also inserted alongside the wires. This tube plays a critical role in the manufacturing process. We'll get to its purpose in a bit. For now, let's focus on the filament and its connections. Now, back to the filament. It is the centerpiece of the bulb's design. It's carefully attached to the two copper wires protruding from the bulb's neck. This connection must be secure to ensure the bulb functions correctly. To ensure a long lifespan and protect them from moisture, the copper wires and the point of contact with the filament are often coated with a special metal called zirconium. This coating is crucial for the bulb's durability. This coating helps prevent oxidation and ensures a reliable electrical connection. Oxidation can weaken the wires and disrupt the flow of electricity, so this protective layer is essential for maintaining the bulb's performance over time. Alright, so let's dive into the next step. After the filament is securely in place, the inside of the bulb is coated with a special powder. This coating helps to diffuse the light more evenly. Once the coating is done, the bulb is sealed. This is a crucial step, as it ensures that the inert gases inside the bulb remain intact, allowing the filament to glow brightly without burning out too quickly. Moving on, the base of the bulb is assembled. The base, typically made of metal, is securely attached to the glass body. This allows the bulb to be screwed into a socket. After assembly, each bulb undergoes rigorous testing. This ensures that it meets all safety and performance standards. Any bulb that doesn't meet these standards is discarded. This quality control process is essential to ensure that only the best products reach consumers. Now, let's talk about the rise of LED bulbs. LED technology has revolutionized the lighting industry. These bulbs are far more energy efficient and have a much longer lifespan compared to traditional incandescent bulbs. They also come in a variety of colors and brightness levels, making them versatile for different applications. The shift to LED bulbs has significantly reduced energy consumption and is a big step towards more sustainable living. In conclusion, the journey of the electric bulb has been quite remarkable. From the early days of Thomas Edison's incandescent bulb to the modern LED bulbs, the technology has evolved significantly. Each advancement has brought about greater efficiency and sustainability. As we look to the future, it's exciting to think about what new innovations in lighting technology might emerge. Thanks for joining us on this illuminating journey through the history and making of electric bulbs.